Now we are live and we are recording. And basically, this is Nick. Do you want to introduce yourself?
Sure. And my name is Nick VanMatre. I work for Archstone, and my colleagues and I have been working on a project for about 6 months now for version 1, and we decided to use RavenDB. So we are in production, so we're just for our first phase, and everything's going great. No performance problems, but as we go through, we are looking to expand and continue our knowledge base, and next step is to load balance, see if we can do load balancing.
Exactly. So this discussion is basically all about how we can get RavenDB to scale. What are the options? How can we integrate it with existing scaling solution and all sorts of stuff like that. What are we looking at right now? So I see some sort of architecture diagram or deployment diagram.
It's pretty much what we have currently right now. This is our first. The one we look at now is our future diagram that we think we might be able to do. So kind of this first part you see here describes how our site is. It's ASP.NET in VC3, and we're using Netscaler to do our load balancing off of that. So basically, all the requests come into our Netscaler appliance, and then that does. Right now, it's configured to around Robin to do a load balance between our IS nodes that we can add, subtract to it. As you can see there, our web app does, right now it talks directly to currently one RavenDB database. It also publishes messages to our service bus and a bunch of infrastructure stuff there. But this picture showing the possibility of using Netscaler as our load balancing for RavenDB also. So basically here the idea is Netscaler, we have the ability to route gets and puts to different actual machines. So we could have multiple nodes for our retrieves, and then have one. Right now we're just thinking one node for our saves, for our puts, and then replicate those to our two read nodes.
Okay. So let me see if I can put it in terms so you know and understand that. You currently have an existing website using RavenDB. You're concerned about future scaling needs. So as the user site grows, you want to see how we can actually scale up the RavenDB side of things. Specifically in your case, you're also interested in the management aspect of that. So, okay, I want to bring up a new RavenDB node, or I want to take down a node for maintenance or stuff like that.
Exactly. It's one thing we currently at the IS sites with Netscaler is we could pull down a node, do our deployments to that node, and then once we've tested it, everything's good, we could turn it back on, and it will replicate those changes to the other nodes. So we could have longer deployment schedules.
The major problem when we're talking about these sort of things for databases is that databases are stateful. The reason that you can actually do that on the website is that the websites basically carry no or very little state of their own. So you can just basically kick one off and everything else just goes along very happily. The interesting aspects of that, let me just pull up my trusty architecture tool. Yes. It's a wonderful tool for architects. So now we have, this is our current stuff. Okay? This is our current deployment. You have, I don't know, application, service bus, ETL, other stuff. And they all go to this guy. Now the problem is that now I actually says that there are several things that we should be concerned here. The first problem is actually that fourth problem is actually of a single point of failure. So we don't want a single RavenDB instance, we want at least two, just so if one is failing, then the other one can pick up the slack. You can set up this up as a master. Let's say the master is orange because orange is good. And okay, so you can set up the master as the orange, and the secondary instance would be the green one. You can, and this is the most trivial example of setting up RavenDB for production. So we have two instances. One, you have set up a master-slave replication. So you have a replication that is one way between these two, like this. And the next step that we need to work on is, okay, what about the management concerns? So let's think for a second what would happen in the following scenarios. What happens when you take this down? So this was just taken down. What will happen now? Okay, so we took this down, and even without anything else, RavenDB will basically redirect all the traffic to this guy, and everything will just work. Now, it's important to understand that the major problem with doing this sort of thing is actually how do you maintain state. So you mentioned that you want to have only a single write node and multiple read nodes. Now, in most cases, you actually say that you don't really care that much about it. Reads in RavenDB are really, 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 really optimized. So they're optimized both at the client side and the server side. So this gets us a whole lot of stuff that just works for us. We don't need to do anything beyond that. Writes are usually where you hit the bottleneck. RavenDB is designed to handle thousands of writes per second. But if you want to go beyond that to tens of thousands or hundreds of thousands of writes per second, you have to go to sharding or some other approach. We're talking about thousands of writes per second in a single database instance. So we have this option of basically master and slave, and it just works. You can take down either one of them independently, but the default behavior of RavenDB when you do something like that is to fail over to the secondary node, but to fail over to the secondary node only for reads. And the reason for that is that when the master node comes up, we need to have some way of actually replicating that information to the master node if we have written anything to the secondary node while the master was down. And that implies that you have master-master application that is a different world than just having a master-slave. Another thing to consider is in your diagram, you had the Netscaler do the splitting of the information at the HTTP layer. That means that from the point of view of your applications, it sees only a single RavenDB instance, right?
Correct.
Okay. That might lead you to a problem because let's say that you're making a write it goes to the write node, but now you have to kick off the replication cycle, and if you make a write and then a read, you're absolutely guaranteed that you'll never get the same value back, okay? Because the forced write goes to one server, the read write goes to a different server. Now, the RavenDB contract ensures that you will always get the latest stuff from the document. So, by that I mean that, session.save changes, session.load, you see?
Mm-hmm.
So load is always ACID. Even the query results are ACID, even though the things that are queried, the index may be base, but the result that you get are ACID. And when you're doing this fashion, you basically are breaking this promise, because the save changes goes to the write node, and the load will go to the read node basically. And that means that you're absolutely guaranteed that you'll get stale information. Now, this may be, yeah, go ahead.
Oh, that's great. Okay.
Now, this may actually be a workable thing for you. So you can say, okay, I can live with that, but there are many cases where this would actually be a fairly surprising thing to see. The think about the common case of editing an entity and then hitting save, and you're being redirected back to the entity details page. You will see all the results as if you haven't edited anything.
Right, which is a problem.
Yes. And what I would actually say is that a better approach, at least, so for production, this is the recommended deployment, what you see on the screen in front of you. So 2 instances with a master-slave replication between them. That allows you to take each of them independently. If you take the master, you're going to deny rights. This is the default behavior. Okay, you can change that, but the default behavior is, in this case, if you take down the server, you can still read, but you can no longer write. If you take this thing, nothing happens. You can read and write with no problems, obviously. Okay, so this is the default deployment for any production scenarios, just because it allows you to recover from a failed database. The more interesting aspect is what happens when you have something, when you actually want to scale. And in those cases, what we do usually say something like, this is the application, this is the bus, this is some sort of ETL, and each of those can you see this now?
Huh?
Okay, so each of those have their own dedicated RavenDB dual servers. So again, each of those has, well, I don't know if you need a dual for the ETL. If it's break, it's usually not such a big deal on an immediate level. But for the bus or for the application, you probably want to have a cluster RavenDB. And the interesting aspect about these sort of things is that for the most parts, each of these systems is actually going to be querying something totally different. Going to be writing something totally different than the other. So a typical example would be that on the application, what is the model that you're using, if you don't mind?
I'm sorry, could you ask so?
What is the model? What sort of an application are we talking about?
For the application, it's a ASP.NET MVC application.
Mm-hmm. And what does it do?
This current one is basically, it's 2 things. It's for our residents to online do payments, check status, for our internal employees to manage customers.
Okay, so let's put it this way. Archstone is in real estate management solutions, right? So basically, I go to you and you own a building and I rent an apartment from you, and you manage that.
That's correct.
Okay.
Yep.
So a typical example of, so I want to pay my rent. So I go into the website and I go into the website. So I'm now at the website. It's black. And now I'm giving you my credit card information. What you're doing that now is that pretty icon? One second, I'm looking for one specific icon that I know. Here we are. So this is what you're doing. On the application, I just gave you my credit card details, and you're creating the credit card details in RavenDB, hopefully in some encrypted fashion, and then you send a message to the bus to actually do something about it, right?
Correct.
Okay. And the bus is going to go ahead and it's going to actually do the payment detail. Payment processed. And the ETL I don't care about. But notice what we usually have here. Usually have two distinct parts of the application of the system are actually doing different things. The application is going to create the payment processing details, and the bus is going to process that and mark it as completed. So because they're doing totally different things and totally different life cycles, the chance for conflicts here is very low. So I would basically say that in this scenario, what we want is just this. So we have master-master replication between those two, actually those four, but you get my drift, and that's about it. So
you're
yeah.
sorry. So between the two, it's a full bi-directional sync then.
Yes.
Right?
Yes.
Okay.
It would complicate things somewhat from the point of view of sending a message to the bus. So what sort of bus are you using?
Rhino service bus.
Okay, so I heard about that one. And yeah. So anyway, so presumably you're going to make some writes to the instance here and then send a message to this guy over here. But there is nothing that actually ensures that by the time that the message reaches the bus, that the replication has happened. So you have to be aware of that in your code and retry the operation if the details haven't arrived yet. Okay?
Okay.
But
I could see that getting kind of tricky, because in some cases you might not know how would you know if the replication actually occurred?
you can check that. There are ways of actually checking if replication code, and you can also check that the way that we actually do that, because in the bus you always have the ID of the message. You can also send the expected e-tag, and you can say, okay, this is this e-tag or later in the bus then.
So the e-tag is replicated would be on the same for both, or?
It would be in the replication replication history, so you can check that that e-tag is in the replication history, and that will give you the values that you want.
Okay, that makes sense. I guess my only question would be is what about like really common data that both sides, the bus and the application, like let's say the customer, is going to share? I mean, is that on its own shard that they're both going to access, or?
I don't see why. Are they both going to manipulate that information?
Probably not.
Yeah, because the reason I'm saying that is that in most scenarios there aren't actually a lot of need to have both ends modify the thing at the same time. So if you talk about the customer, well, the application never creates a customer. The application may the application may submit a request to become a customer, but this is handled by a totally different application inside the application that is internal to your organization.
Right.
Eventually, you have in the bus create customer message that goes and does everything, and then they get replicated to that side.
In our current scenario, the customer is always going to be created through the ETL from another source system. So we save it to Raven, and then we actually throw a message on the bus saying, "Hey, new customer created." We have other processes that go downstream from that message, like the reporting database, send off emails.
Yeah, makes sense. The one thing that I want to stress here, this is a fairly complex setup. You only want to go that route if you actually have valid reason to want to do that. I don't know what your traffic number are, but for the most part, I would be very surprised if, as currently stand, a single RavenDB server or RavenDB cluster wouldn't be able to process what you want.
Okay.
You're talking about, I don't know, several million requests a day. Is this in the range?
Yeah, I mean, I don't foresee we really need that for the load balancing side of things for the performance. It's more of looking into ways to ensure that we're up all the time for deployments and just best case scenarios.
Yeah, sure. In those cases, I would say that you want to go to this setup.
Okay.
So basically just standard application setup, and that's it. You don't need anything beyond that.
Okay.
Wonderful. Okay. Any additional questions?
So within this setup, this is on a single shard. You're not looking, in most cases, you think you should be able to just do it on one single shard rather than...
Yes, yes.
Okay.
The basic idea is that you don't want to shard and you don't want to go into this sort of setup unless you absolutely have to. Because going to sharding, go to that involves a whole lot of headache, how do you say that? Suddenly lost the ability to say my head hurts. Yes, headache. Yeah, sometimes it just happens to me that I lose the ability to say a word. So, going to sharding, going to multiple master databases is a fairly complex scenario. You want to avoid it if you can, because this sort of setup is much simpler to think about or reason about and to basically just work with. And it's scaled to a fair amount of work. And for the high availability store, you have the clustering scenarios.
Okay. Very interesting.
Yeah, wonderful. Any additional questions?
Not at this moment, yeah.
Okay, wonderful. So, thank you so much for agreeing to record this. Hopefully, we're actually able to record it. I actually managed to press record this time. So, right now, I'm going to say goodbye to anyone who have listened. Hopefully, you thought that this was interesting. And bye-bye, and hope that you have a happy time using RavenDB.